Good afternoon, students. Welcome back to Signals and System online video lecture series. In this class, I am going to give the review of the systems. So far, we have discussed the four types of systems, that is continuous time system and the discrete time system. After that, we have discussed the static and dynamic systems. The next one, we discussed the causal and the non-causal one. And the last one, in the previous class, we discussed about the linear and non-linear systems. So some of the students from the CSE and IT, they asked me to revise the causal and non-causal and as well as linear and non-linear systems. So I'm going to revise not only those two systems, I'm going to revise whatever I have explained in previous classes, various systems. I'm going to revise the four systems, in which the first one is nothing but it is a continuous time and the discrete time system. So system is nothing but it is a physical entity which can manipulate the signal, input signal, which process the input signal and produce the required output signal. That is nothing but it is a system. It is a meaningful interconnection of various components, and it is used to provide one particular function that is called as a system. Coming to the first system, that is a continuous time system. A continuous time system is a one which transforms the continuous time input signals into the continuous time output signals. So we know that in the previous classes we have studied the continuous time system. Then I am taking the example of the continuous time system. Here I am going with a system. This is assume that it is a system. To which I am giving the input is continuous time. Continuous time signals will be denoted with x of t or y of t, where t is a independent variable. Generally it is a time. And it is a system. We have given the input is a continuous time signal, then the output is also the continuous time signal, that is about y of t. These type of systems are named as continuous time systems. So the relation between the x of t and y of t, x of t is nothing but the input, and whereas y of t is nothing but the output. So that we have the x of t, that as input, and it has been entering into the system, so that some operations are going to operate on that input signal. That operation is denoted with t. T is nothing but it is a transfer function. Due to the operations performed on the input signal inside the system, it is going to give the new type of signal, that is nothing but y of t. Here x of t is what? It is the input. Y of t is the output. X of t is getting into the system, so that it may undergo with the many manipulations inside the system. That manipulations nothing but that are the operations are going to performed on the input signal, that is x of t. Due to that manipulations and the operations, we are going to get the new signal, that is y of t. If a system completely process with the continuous time signals, that is input and output are the continuous time signals, then that system is named as continuous time system. So best example for the continuous time system: amplifiers, filters, integrators, differentiators, all these nothing but these are the continuous time systems. And relation between the output and input, that is nothing but y of t. We can get the y of t is by applying some transfer function on x of t. X of t is nothing but the input signal. If we are good at the continuous time signal, we can continuous time system, we can easily describe the discrete time system. A discrete time system is a one which transforms the discrete time input signals into the discrete time output signals. Very, very simple. If a system completely deals with the discrete time signals, then that system is named as it is a discrete time system. Then I am going with a discrete time system. This is a discrete time system. so that it can accept only discrete time signals. Discrete time signals can be denoted with the x of n, and here x of n is the input, x of n is the input which is getting into the system, so that inside the system this signal, that is discrete time signal, may undergo with the many manipulations. Due to that manipulations, we are going to get the new discrete time signal, that is nothing but y of n. Here in the first example, it is a system, it is input is x of t, output is y of t. This complete system is dealing with the continuous time signals only. X of t and y of t is nothing but continuous time signals. Whereas in the second case, it is a discrete time signal, discrete time system whose output is a discrete time signal, input is a discrete time signal, and the output is also discrete time signal. That means if a system completely deals with the discrete time signals, that system is named as it is a discrete time system. The best example for the discrete time system, that is a microprocessor, semiconductor memories, and shift register. All these comes under discrete time system. Coming to the static system and the dynamic system. Static system is a one in which if the output is purely dependent on the present input signal, then that system is named as static system. And if the system output is not only dependent on the present input signals, if it depends on the past input and the previous inputs also, then that system is named as a dynamic system. Static system is also called memoryless system, whereas dynamic system is called as memory system. So in this case I am going to explain some of the example. Here static system, a system said to be static, that is memoryless, if the response, that is nothing but output, is due to the present input signal alone, then that system is named as a static system. For example, if you go with the static system example, I am having the one system. This is a system. Assume that it is a system. It is a system, so that I am going with it is a system whose output is x of t, and due to the manipulations inside the system, we got the output is y of t, and due to the manipulations inside the system, we got the output y of t is nothing but some of the operations performed on the input signal inside the system, that is x of t. T is nothing but it is a transfer function. Due to this operation, I got the output at the output side, that is x of 2t. X of 2t, that means what? I got the output y of t is equals to x into 2t. We should test this system whether it is static or dynamic. Simply you can classify this system is continuous time or the discrete time. Y of t and x of t, both are the continuous time signals, so that the given system is about the continuous time system. But now we have to test for the static system. Static system means if the system output is purely dependent on the present input signals alone, then that system is named as it is a static or memoryless system. Otherwise it is a dynamic system. So that you can take the some combinations of inputs such that you can get the what is the type of the system it is. Now I am taking the t is equals to 0. If t is equals to 0, that means what? I am getting the y of 0 as an output at t is equals to 0, and due to the input, that is 2 into 0, that is 0. That means what? I am getting the y of 0 as an output at t is equals to 0, due to the input x of 0 at t is equals to 0. Both are 0, 0. Both are same. So that means what? Here the present output is dependent on the present inputs only. Then I am going with the another case now. T is equals to minus 1. If I substitute t is equals to minus 1, this is y of minus 1 is equals to x of minus 2. X of minus 2. Then plot this 1 and minus 1. This is 0. I can write. This is minus 1 and this is minus 2. That means what? I am having the output is at minus 1. I am having the output is at minus 1, and this output is due to the x of minus 2. X of minus 2 means what? This one. That means what? It is the present state output. It is dependent on the previous value, that is the past value, past input value, so that it is the dynamic system. If we test at t is equals to 0, it is showing that it is a static system. But we have to go for all the possible combinations to test whether that is a static or a dynamic. With the second case, we are getting it is the output is dependent on the previous value of input signal, so that this system is named as a dynamic system. For example, I am going with the t is equals to 1 now, positive. So that y of 1 is equals to I am getting the x of 2. So that plot this y of 1, this is 1 and this is 2. That means what? I am getting the y of 1 at t is equals to, I am getting the y of 1 at t is equals to 1 due to the x of 2 that t is equals to 2. That means what? This 2 is the future for the 1, so that this is output is not only dependent. For the first case, we are saying that with the first case we can say that output is dependent on the present input signal 0 to 0, that is present. And with the second case, we came to know that the output is dependent on the future previous values of inputs also. Third case, we came to know that the present state output is dependent on the future values. Then in that case, this type of system is named as it is a dynamic system. Dynamic system is nothing but a system whose output is not only dependent on the present input signals but also dependent on the previous and the future input signal. That types of systems are named as, these are the dynamic systems. Here we can go with the one more important note about the dynamic system and the static system. If any continuous time system is described by a differential equation, or the discrete time system described by a difference equation, then that system we can directly say that it is a dynamic system. Note, very very important note here. Now I am going with one particular note here. Note is about the static and the dynamic system. For example, I am having the system output that is in the form of differential equation. Output of a system is represented in the differential equation with respect to the continuous time signals. That means what? I have the d square y of t by dx square plus dy of t by dx, like that I have the equation. And here x of t, y of t, x of t, y of t, that means what? These are the continuous time signals, so that this system output expression is defined in a differential equation. If a system's output expression is defined in a differential equation, directly you can say that that system is a dynamic system. That system is a dynamic system. Now that system, by seeing the differential equation, we should say that that system is a dynamic system. And coming to this is about continuous time signals. For example, if it is discrete time signals are there, that means what? For example, I am having the y of n plus 1 minus y of n minus 1, like that. Output expression is denoted with respect to the difference equation. Now this is nothing but it is a difference equation. Y of n plus 1 minus y of n minus 1, it is nothing but it is a difference equation. For example, if a system output is described with a difference equation in a discrete time, with the discrete time signals, then obviously that system is classified as dynamic system. You have to note the very very key point from the basic definition of the static and dynamic system. It is very clear that static system is a one whose output is purely dependent on the present input signals alone. Then that system is named as static system. The other name for the static system is a memory system. Coming to the next one is a dynamic system. If the system output is not only dependent on the present input signals, if it is also dependent on the future input signals and the past input signals, then that system is named as dynamic system. And in the in case of the static and dynamic system, we have to go with one particular note. If a system output expression is described with a differential equation, if it is with the continuous time signal, then that system completely a dynamic system. If a system output is described with a difference equation, with the discrete time signals, obviously that system is a system is a dynamic system. So that we have discussed the two systems that are continuous time and the discrete time. And the next one I am going to talk about the causal and non-causal system. Causal and a non-causal system. Causal system is a one. If the system output is dependent on present and past input signals, then that system is named as causal. Otherwise, that will be the non-causal. Definition is very, very simple. That is, if a system output is dependent on present input signals and the past input signals, that system is named as it is a causal system. If the system output is dependent on the future input signals, then that system is named as non-causal system or anticipatory system. So that I am going to define the causal system and non-causal system. Then causal and non-causal system, I am going with a basic block diagram of a system. This is a system. Assume that it is a system whose input I am assuming is x of t. When x of t get into the system, inside the system, it may undergo with the many manipulations. Due to that many manipulations, I can get the output is y of t. If y of t is purely dependent on the present input signals and the past input signals, then that system is named as it is a causal system. That system is named as causal. If a system output is dependent on the present inputs and the past inputs, then that system is classified as causal system. Otherwise, if y of t is nothing but what? It is the output. Output is dependent on the future inputs, then that system is named as it is a non-causal system. That system is named as non-causal system. The other name for the non-causal system is anticipatory system. This system name is anticipatory system. And whereas causal system name is non-anticipatory system. So that there are two systems we can have, that is causal system and non-causal system. Causal system is nothing but if the system output, is dependent on the present input signals and the past input signals, then that system is named as causal system. If the system output is dependent on the future inputs, then that system is named as non-causal systems. Likewise, we can have the causal and non-causal systems. Then I am going to describe the causal and non-causal systems with some examples. A system is said to be causal if the output of a system at any time depends only on present and past values of input, but not on the future inputs. In other words, we can say that a system is causal if the response or the output does not begin before the input function is applied. That is a causal system, is also called as non-anticipatory system. Causal systems are real-time systems. They are physically realizable and whereas non-causal systems are physically not realizable. So that if you go with the examples, we can come to know which system is a causal system and which system is a non-causal system. Then I am going with the one particular example. Y of t is equals to, I am going with the y of t is equals to, I have x of t plus 1 by x of t minus 1. First try to convert that is into the block diagram form. First I am going with the block diagram form. I am having a system, draw the system, block diagram. This is a system. It is a system whose output is y of t. We have y of t, input is x of t. That means what? We have the y of t due to some functions applied on the x of t. From the question what we have, y of t is equals to what? We have x of t plus 1 by x of t minus 1. That means what? X of t is getting inside the system due to some operations and the manipulations. We have been getting the y of t. That y of t is nothing but x of t plus 1 by x of t minus 1. Now substitute various values for the t now. Now substitute various values for t. That is what? Y of t is equals to, I am going with x of t plus 1 by x of t minus 1. Now t is equals to 0. Substitute t is equals to 0 means y of 0 is equals to x of 0 plus 1 by x of 0 minus 1. It will be the 1. So that plot this y of 0. Let assume that y of 0 is the present output. It is a present output. It is a present output. So that means what? Here this is plot. This is 0. This is again it is having the 0. Again it is having the minus 1. See this one. This is 0. This is y of 0. This is y of 0. We got the output is at y of 0 due to what? X of 0. That means what? X of 0 is a present state input, and due to another input, that is x of minus 1, and this minus 1 will be there previous to the 0, so that it is y of 0 is a present state output. It is dependent on the present inputs and the previous inputs, so that with the first condition we can know that it is a causal system. But we have to verify all the possible combinations, Then I am going with the t is equals to 1 now. T is equals to 1. If I go with the t is equals to 1, y of 1 is equals to x of 1 plus 1 by x of 1 minus 1, that is x of 0. That means what? Y of 1 is a present state output, and x of 1 is a present input, and x of 0 is the previous input. We are saying 1 is a present state, 1 is a present state input, so that 0 will be the previous state input. So that in this case also y of 1, if it is 1 is a present state, present to present, and it is a past, so that it is dependent on the present and the previous input. So that I am going with the t is equals to minus 1 now. T is equals to minus 1. If I go with t is equals to minus 1, y of minus 1 is equals to x of minus 1 plus 1 by x of minus 1 and minus 1, that will be the minus 2. That means what? Here we will be having one particular condition now. Y of 1 we are assuming it is a present state output. It is dependent on the present state input, but minus 2 will be the future to the minus 1, so that you go with the some plot. This is minus 1 and it is minus 1, and it will be the, so now it is minus 1. It is, we are getting the output is at the minus 1, and this minus 1 output is dependent on the minus 1 at t is equals to minus 1 input, at t is equals to minus 2 input, and so that this is also the past value only, So that this system, with the three examples, we came to know that the given system output is dependent on present and as well as previous inputs or the past inputs, so that this given system is a causal system. If a system output is dependent on the future input also, then that system is named as a non-causal system. Then the system is named as non-causal system. I am going to explain that non-causal system also. For example, if I go with the one example that is here, I am going with the one example. X, I am having a y of n is equals to I have x of minus n. This is a system. So that then first draw the block diagram of a system. This is a system whose input is x of n and it is manipulated inside the system due to the transfer function, so that I got the output, we got the output is y of n. So x of n is an input, y of n is the output. It is completely discrete time system. That means what? It is completely dealing with the discrete time signal, so that it is a discrete time system. So that I can find the relation between these two. Y of n is nothing but we have the transfer function inside the system. That is nothing but operations will be performed on the input signals inside the system. This is a input. When it is getting inside the system, it is going to be operated with some operations. That is nothing but a t. That is what transfer function. And due to that one, y of n is equals to, by applying the transfer function on x of n, we got the y of n is x of minus n. Now we have to test whether the given system is the causal system or a non-causal system. Go with the various values of n now. Now I am going with n is equals to 0. If n is equals to 0, that is y of 0 is equals to x of 0. That means what? If y of 0 is a present state output, it is dependent on the present input only. Y of 0 to x of 0. Then if I go with x of minus 1, so that y of minus 1 is equals to x of minus 1, that will be the 1. X of minus 1 will be the 1. So that you go with the 1. This is minus 1, this is 0, this is plus 1. We have the output is at what? We have the output is at n is equals to minus 1. We have the output is here, but this output is due to x of n. This output is due to x of 1. This 1 will be the future to the minus 1. This 1 will be the future to the minus 1, so that here the output is dependent on the future value of input. Output is dependent on the future value of input, so that no need to go for the various cases now. With these two cases only, we came to know that the given system is a non-causal system and anticipatory system. This system is non-causal or anticipatory system. Likewise, you can test any system. With the present inputs and the past inputs. Likewise, we can have the causal and non-causal, and if the time permits, today I am going to revise the linear and non-linear systems also. So students, and try to write the notes from the shared videos, and try to practice the more problems in the signals and system. Then only you will get the complete understanding of the signals and system. Learn the basics from the video and try to solve the more problems and based on that particular topic, so that you will be good at the signals and system.